So yeah, I would agree. When you do the cube root, like Lauren's saying, you can put negative numbers in there. You can get negative numbers on your cube root and still get an answer. So I would amend this one. You don't need the 0 is less than or equal to x. So you only really need to put that piece there if it's an even root where you could possibly get negative numbers underneath the radical. So it's not like it's always, and it doesn't always have to be 0. Like, as I was walking around, I saw Jonah had put in a -1 right there because he thought -1 would, like he was thinking about putting that lower boundary. But he thought -1 was the number because -1 plus 1 would still work. It would give me 0. So you might have to change what that lower limit is, depending on what the problem is. But x less than 7 should be your correct answer there. So make that change. For odd roots, you don't need to restrict it to positives only. Are you okay with the blue and the red? The blue is what?
I think it needs this 0, didn't it?
Oh.
I got a little confused for the fact that the inequality sign was facing towards the x, but I still would think that it needs a 0 because you can't do a negative.
Right, you can't do a negative under that square root, right? So you might be thinking about the 0. And I like what you're saying. You're getting a little bit confused because of the sign, right? So can I just make a number line right here? There's 9. Here's 0. You okay with that? And we can be greater than or equal to 9. So remember, you would put a closed circle right there. And then your shading would be over here. If that's the direction that you shade, do you have to worry about the negative at all? No. So I think we don't need the negative. Like 9 is greater than 0, so if we have to be greater than 9, we're okay. Yeah. So I think this one is good. I agree. And then this one, are we okay with that we put the 0 there? Yeah, because it is an even root, it is a square root, and we can't do even roots of negative numbers, so yeah, we should have that lower limit of 0. Okay, so I agree with that one. So I did those 3 on purpose, right? To show you an odd root where you don't need to restrict it. To show you one that was an even root where it's greater than something, so I don't even have to worry about negatives. Okay, and then to show you another one where, yeah, we're going to have to put a stop on that so we don't do any square roots of negative numbers. Okay, your homework assignment. Oh, wait, I got to do nonlinear. Ooh, Alex is excited. Just smiled really big. Okay, this one won't take us very long. We got a nonlinear system. I forgot they squeezed that in here. We got y squared equals 4x plus 17. And we got y equals x plus 5. This is called nonlinear system because one of the equations in the system isn't a line. This one's a line, right? Y equals mx plus b. Do you recall from before Thanksgiving break? What would this shape be? Y squared equals 4x plus 17. That's a parabola. If you have y squared or x squared but not both, that's a parabola. And since it's a y squared parabola, isn't it a parabola that opens on its side, like it's opening to the right, okay, or opening to the left? And then, can you imagine how a line, like I'm not graphing that one in the coordinate plane, but can you imagine how a line might intersect that parabola? Like there's different possibilities. I could draw a line like this. Wouldn't that be intersecting the parabola? And then if I'm looking for the solution to the system, those are the points of intersection. I could have 2 points of intersection. Okay. Or like it is possible that your line is, we call this tangent to your parabola. So it just touches at a single point and moves on. Okay. So then you could have one solution. And could you even imagine a line that doesn't cross your parabola? So I could draw like a green line over here, way out over there, and it's never going to catch the parabola. So I can have one solution, I can have 2 solutions, I can have no solutions. What methods do you have to solve systems? substitution and elimination. Either one will work. What do you guys feel inclined to do looking at those two equations? Substitution. Yeah. I think that's great because you know that y is equal to x plus 5, so make the substitution. Sub x plus 5 in for y. So that'll be x plus 5 quantity squared equals 4x plus 17. This will take us back to yesterday. X plus 5 times x plus 5. FOIL that out. X squared plus 10x plus 25 equals 4x plus 17. Remember, that's not x squared plus 25. Bad. I did x plus 5 times x plus 5. And then very similar to the questions that we had asked on our homework, when your equation has x squared and x in it, you gotta make one side equal to 0 and solve. So I'm going to subtract 4x and subtract 17. What does that get me? X squared plus 6x plus 8. Thank you, Jake. Can you factor that? My factors are pretty easy in this chapter. If you get to this point, you get rewarded with an easy factor. Factors of 8 that add to make 6. 2 and 4. Okay, so you're getting 2 answers for x. Okay. That means that if I go back up to my drawing, I must have 2 points of intersection because they have like different x values. Okay. So my answer should be the point of intersection. I know my x's are -2 and -4. Just got to plug them in to get y. You know, you can plug them into either equation up at the top, but probably it's easiest to plug it into y equals x plus 5. So -2 plus 5 will give me 3, and -4 plus 5 will give me 1. So we're going to sub x equals -2 and x equals -4 into y equals x plus 5. Just so you know what we're doing. That gives me 3 and 1. If you wanted to make sure that you were right, you could take those x and y's and plug them into the first equation, and they should also work. Okay, but you have 2 points on that one. It is possible to get 1 point, okay, like if you factor it and you get the same answer both times. Okay. And if it doesn't factor, if it's an imaginary answer with quadratic formula, they don't intersect. Okay, okay, you do have a homework assignment. It's pretty short, what, 8 problems? Not bad. It's on your gold sheet.